3 years ago, a piece of American technology left Earth. It wasn't supposed to become part of the moon. It wasn't a lander. It wasn't a probe. It wasn't carrying astronauts. It was the second stage of a SpaceX Falcon 9 rocket, the same rocket that has flown into space over 600 times. But this flight ended differently. On August 5, 2026, at 2:35 in the morning, that stage slammed into the moon, traveling at roughly 5,400 miles per hour. No atmosphere to slow it down, no brakes, no last-second rescue, just 7 times the speed of sound, and the moon. And the strangest part, nobody sent it there. Physics did. Let's go back to the beginning. On January 15, 2025, a Falcon 9 lifted off from Florida, carrying 2 spacecraft toward the moon. One was Firefly Aerospace's Blue Ghost lander. The other was Resilience, built by Japan's iSpace. The rocket did its job. It delivered both spacecraft on course. Blue Ghost would spend 2 weeks on the lunar surface. Resilience would crash during its own landing attempt. But the Falcon 9's upper stage had nowhere left to go. Most upper stages fall back and burn up within days. This one didn't. It had used too much fuel getting its payloads to the moon. It was left drifting, looping around Earth, too weak to escape, too fast to fall. For a while, it just wandered. In space, once an engine shuts off, there's nothing to stop you. No air, no friction. You simply keep moving, and gravity decides where. Earth pulled on it, the moon pulled on it, even sunlight gave it a faint, constant push. Month after month, that push added up. Astronomers kept watching. One of them, Bill Gray, tracks exactly this kind of leftover space hardware. Piece by piece, observation by observation, the picture became clear. The rocket wasn't just going to pass the moon, it was going to hit it. By the summer of 2026, scientists had narrowed it down to within a few kilometers and a location, Einstein crater, on the moon's western edge. There was no way to stop it. No engines left, no fuel, no plan. Just a countdown written in gravity. But this time, something unusual happened. Scientists didn't just witness an impact, they planned for it. 23 researchers built an international observing campaign. NASA tracked the stage from lunar orbit. South Korea's Danuri spacecraft photographed it before and after. Telescopes across the world turned toward one small patch of sky, because this crater would be different. Most craters come from asteroids we know nothing about, random rocks from the dark. This time, scientists knew exactly what was coming: its mass, its speed, its material, even the minute it would strike. It was a controlled experiment written by an accident. When the moment came, it didn't go quite as planned. The impact site was bathed in sunlight, which should have made it easier to see. Instead, the flash was too faint, too brief. Not one telescope caught the actual moment of impact, but they caught something else. In Chile, the Very Large Telescope was watching, and it detected something rising from the dust: sodium and lithium, glowing for 5 to 10 minutes after impact. The sodium came from the lunar soil itself, thrown into space by the force of the crash. The lithium likely came from the rocket. For the first time, scientists read the chemical fingerprint of a human object the instant it became part of another world. It's a small detail, but it matters. Every future mission to the moon will kick up dust like this. Landers, rovers, eventually astronauts. Understanding this dust protects the hardware and the people who come next. Which brings us to a bigger story. This wasn't the first accident like this. In 2022, a mystery rocket body struck the moon's far side, leaving behind a strange double crater. Now, this. 2 accidents, both from rockets nobody had a plan to bring home. And the moon is about to get crowded. NASA is preparing to send astronauts back. Private companies are racing to build landers, bases, rovers. More missions means more hardware. And more of that hardware will eventually run out of fuel, lose control, and become debris, just like this Falcon 9 stage did. Right now, there is no rule book for this. SpaceX says it's working with NASA to prevent future uncontrolled impacts. But for a rocket already committed to deep space, there may be no way to bring it home. For over 4 billion years, the moon has kept a record of everything that's ever struck it. Asteroids, comets, debris from the birth of the solar system itself. Now, a new scar sits in that record, not carved by nature, carved by us. A machine built on Earth, launched by human hands, drifting for 19 months through the dark, until gravity finally decided where its journey would end. The moon didn't ask for this collision. It simply received it, the way it has received everything else for billions of years. But as humanity prepares to return, to build, to stay, this quiet impact leaves behind one question. We already know we can reach the moon. The question now is, what are we willing to leave behind when we do?